Lesson 19 Project Help video. The queen has been studying flying unicorns because the unicorn who left the eggs behind was a flying unicorn. But she knows there are also a number of large earthbound unicorns plaguing the outlying areas of the kingdom. In order to determine zones of safety and their range of motion, Queen Margaret does some research on the average speed these animals can reach, which leads her to graphs of radical equations. See if you can help the queen identify the best way to present the information to the people in the kingdom. The maximum walking speed in feet per second of a large animal can be modeled by the equation s equals the square root of g times L, where s equals the speed in feet per second, g equals a constant rate of 40 feet per second squared, and L equals the length of one leg of the animal in feet. What is the domain for s of L equals the square root of g times L? So, we want to know what the domain is. So, our domain, remember, is our value of, normally it'd be x in a normal equation, so it's whatever our input value is. In this case, our input value is an L. So, if we substitute in our g value, we'll end up with s of L equals the square root of 40 L. So we need to know what we can plug in for L. What are possible values? Well, let's think about it. If we plugged in negative numbers, then a negative number times a positive would give us a negative, and the square root of a negative would be an imaginary number. But can we have a speed that's imaginary? Well, no, we can't have a speed that's imaginary. So that means we can't put in negative numbers. If we put in 0, could we have a speed of 0? Because 0 times 40 would give us a 0, square root of 0 would be 0, so that would leave us with a speed of 0. Well, we can have a speed of 0, but that doesn't really, can we have an L that is actually 0? Can we have a length of an animal's leg be 0? Well, if they have a leg, it's not going to be 0 feet. So, but if we plug in any positive number, then we'll get a leg that's whatever feet long, and we'll end up with some sort of positive walking speed. So that means that our L has to be greater than 0. So that would be our domain, L greater than 0. The maximum walking speed in feet per second of a large animal can be modeled by the equation s equals the square root of gl, where s equals speed in feet per second, g equals a constant rate of 40 feet per second squared, and L equals the length of one leg of the animal in feet. What is the range? So remember, the range is your output value, so that's going to be our values for s. So we figured out in our last one that our domain for our equation here is that L is going to be greater than 0. Well, if I plug in a positive number and I multiply times 40, I'm going to get a positive number, and I'm going to take the square root of a positive, so it's going to give me a positive number. If I take the square root of a positive number, am I ever going to get 0? Well, no. Am I ever going to get a negative? A square root of a positive number is always going to give me a positive. So that means that because our L is always greater than 0, that means that S is also always going to be greater than 0. So our range is S greater than 0. That's our possible output values. Refer to the previous two questions. Based on your previous answers and the equation for the maximum walking speed of a large animal, what does a graph of S of L look like? Well, we have our equation, remember, is S of L equals the square root of 40L. We had that our domain is L greater than 0. Our range is S greater than 0. So if we draw a graph, we only need the first quadrant. So our our x-axis here is labeled as L, and our y-axis is labeled as S because that's our inputs and our outputs. And we know that they're both going to be greater than 0. So we need to find another point to be able to model what this looks like. You could just type this into a calculator, graphing calculator, and see what it looks like. Or if I just say, let's say we have 40 here. So if I put 40 in for L, that would have 40 times 40, which gives me 1,600, and then I would be taking the square root of that, which would just give me 40. So I have a point 40, 40. So I would have 40, 40. So I would have a point here at 40, 40. And then since it's a radical, it's going to look like a half of a parabola turned on its side. So it's going to be kind of curved like that. So that would be what our graph of S of L looks like. Like it's kind of half of a parabola on its side. Hope this helps you out with your project 19.